I have a green light. Eeny, meeny, miny, mo, testing out the radio. Well, hi, everybody. My name is Ernie Hayden. I work for a Canadian engineering company called BBA. We have an office in Calgary, and we have offices across Canada and one in the U.S. I'm a U.S. citizen, but don't hold it against me. I did not vote for Donald Trump. And I've been declared once as an honorary Canadian because I knew the time difference for Newfoundland versus Halifax. So anyway, I love this country. You guys are amazing people, and I thank you for the opportunity to talk. So I was asked to talk about IT versus OT, and I really didn't know about what kind of audience we'd have. So is there anyone here who knows what OT is? Okay, maybe what, 22.6%? That's okay. All right, so this is more of an education between IT versus OT. We can go in more details on other things if you want. But the bottom line is that, believe it or not, this is a big deal in the industry, especially for industrial organizations, because the OT, or operational technology people, don't trust the IT people, and vice versa. So you'll learn more about this. So what I want to do is, for the agenda today, is just do some quick definitions about IT, OT, and ICS, or industrial control systems. Talk about some architectures, because there's some architectural elements in OT that are really, you need to know these in OT 101. So it's probably useful for you to be aware of them. And then we'll talk about the differences between IT and OT, and then, what considerations should be at the end. Now, the title of this was Who Wins, or something like that, Who Loses. I'm sorry, that's not my game. My game is I want everybody to be successful. So you'll see at the end how I propose we move forward on that. All right, so some definitions. Information technology, everybody's heard that, and basically it's processing data. That's the easiest way to think about information technology. Email, databases, ERP, PowerPoint. You're processing data. OT, or operational technology, really applies to processes. And I'm going to read the definition, even though I know you can do that. This is hardware and software that detects or causes a change through the direct monitoring and or control of physical devices, processes, and events in the enterprise. Just to make this very simple, imagine your thermostat in your house. That's essentially an OT device. You set a temperature for heat or air conditioning or whatever. The sensor detects the temperature. It maybe affects everything ranging from a coil to, which, remember the bimetallic coils in the old systems? Okay, you've got that, but it's also got another sensor or whatever, and then it basically sends a signal to your air conditioner or your heater to say go on or go off, or turn the fan on or turn the fan off. That's a process, and that's operational technology. The third term to be aware of is industrial control systems, or ICS. I can't tell you the number of times I talk to people and they say, tell me about SCADA. And I go, okay, what would you like to know about it? Not that I'm that smart guy of a guy, but I know quite a bit about it. And then they say, well, but I just want to know about SCADA. Everything's SCADA, right? And I said, no, that's not true. SCADA is an element of industrial control systems, because industrial control systems constitutes SCADA, DCS, or distributed control systems. Sometimes it includes other things called programmable logic, or programmable logic controllers, PLCs. The point is that SCADA is ICS, but ICS is more than SCADA. So just for your awareness. Okay, so those are the terms, IT, OT, and ICS. So the next part is to talk about architectures. Now, I'm really only going to dwell on one picture for IT, because you guys are smart enough to know that. At least I hope you are. And this is a classic IT architecture. Switches, servers. I've even got the cloud. Can't forget the cloud because that's all over the place now. Wireless access points and so forth. This should not be an unusual architecture for you to see. However, for OT or operational technology, there's some very different ways of looking at architecture. Is there a laser pointer? No? Okay. I'll just point at the screen. No. It's okay. It's fine. Don't worry about it. If I'd thought about this, I would have brought mine. By the way, don't bring a laser pointer to Saudi Arabia. They're illegal and you'll be thrown in jail. Okay, so this is an architecture block diagram first on industrial control systems. It's something known as the Purdue Model. It's actually got an ISA standard against it. And it came from Purdue University, where they were looking at how in the world can I look at a manufacturing environment and how do I make a hierarchy of my systems. So this Purdue model, this is a very simple diagram first, and it breaks it into 3 primary zones. The bottom one is called the control zone. Imagine that's your factory. That's your power plant. That's where the dairy is processing the milk and so forth. Then you have a DMZ, demilitarized zone, fairly classic. It's strictly to be a point of separation between the zones. And then you have the top zone called the business or enterprise zone. The business or enterprise zone is IT. That's where the IT architecture fits. But when you look at these zones, especially in the control zone, starting at the bottom, you'll see the level 0. That's where all the work is done. It's called the process input-output devices. This is where your sensors are, your valve actuators, your valves, your temperature monitors, flow controllers. Essentially, all the work is being done down there in the factory, or the power plant, or the refinery. Above that is level 1. First box is Safety Instrumented Systems, or SIS, and SIS is a big deal because this is a place where you want to have systems that require no people to get involved, because once the plant goes haywire, the SIS systems will come into play and shut things down. Anyone who works at a refinery, there are very specific SIS systems. There are SIS systems that maybe detect ammonia leaks or something like that. So it's just a place where you're building in safety into your industrial control system, and you'll see some more about that later on. Level 2 is area and supervisory control. This is where you have workstations, you can type in commands, you can modify what the set points are and so forth. And then site manufacturing operations and control. This is pretty much where the bosses start putting in the orders and so forth. Now, the control zone can connect to the enterprise. For example, if you're using SAP as your ERP system, the factory needs to talk to SAP to say, well, I've made 37 widgets today, and we put them on 6 pallets, and here are the pallet numbers and so forth. So that's something to be aware of. So for Purdue Model, if you ever want to go into ICSCERT, just nail this. Learn this inside and out. It will help you as long as you can imagine. In fact, I've actually used this very diagram when I had a conversation once with a guy at a chemical company because he was trying to understand why he couldn't have signal flow going certain ways. And I literally took this and drew lines. Here's where the signal is. It goes to here, it goes to here, and then it goes to here. Now, this is not a very good, it's an eye chart. Right? I'm supposed to say that. Eye chart, Stuxnet, whenever you give a security speech. This is an eye chart from ENISA. ENISA is European Union Network and Information Security Agency. Lots of good information on all sorts of security issues. This is their view of an industrial control system. And you can see they've broken it down by different areas, like the bottom, it says production and control processes. That's levels 1 and 0 combined. Level 2 is supervision and monitoring. Level 3, the DMZ, is built in there someplace. And then level 4 goes up to the enterprise. And then, like all good government agencies, this is the U.S. Department of Homeland Security and NIST view of what this looks like. And I hate this diagram, but I had to throw it in because everybody has to see it. Let's talk about security for these systems. Excuse me. If you take a basic security class, you're always going to learn about the CIA triad for enterprise security. So you want to make sure that all your data and signals are confidential, they have integrity, and they're available. That's for the enterprise, CIA. Pretty easy to remember. However, when you walk into the OT space, they're not so worried about the confidentiality of the signal as they are the availability of the signal. So the model is really AIC. You want to make sure the signal's available because those processes are going all the time. If you stop the signal, you literally can cause the plant to fail. There was a paper plant near me that I lived outside Seattle. There was a paper plant near me that had a power failure. And it took them about 3 weeks to clean up the site because they lost a signal, i.e. they lost their power. And all this pulp was all over the place and sheets of ooey-gooey stuff intended to be made into paper just decided to fall all over the floor and the machines and the piping and everything else. So that's why availability is really, really, really critical. So AIC. There's one other aspect here, and some people will say this, is besides AIC, the systems have to be safe, and they have to be reliable and have resilience. If you think about this, if you are working on at a refinery, how many times do they talk to you about safety? All the time. Same thing for an industrial facility. Safety is number one. BBA, engineering company, safety is number one. Resilience and reliability excuse me, is really critical because what will happen is you might go into a plant and see they have a lot of redundant operations. To give you a sense of this, if I go into the enterprise and I was trying to build in resilience, I might have 2 or 3 email servers that are running in parallel all the time so that if one fails, then I have email going on all the time. We all know that's usually not useful, it's expensive, and the mirroring is usually a hiccup. So it's just as easy to have one and just send everybody the message to say email's down for 5 minutes, or switch to Gmail. Another way to look at this model is when you take a company and kind of like lay it out. This is something I built for a utility quite a while ago. And essentially you got the enterprise, the utilities enterprise operations. So they handle credit cards. They deal with things, a regulation in the States called Sarbanes-Oxley. They have their selling aspects, their stores, their call centers. HIPAA is for health security, if you will, for health insurance and health systems. And it's all usually TCP/IP is the protocol, and it's CIA, confidentiality, integrity, availability. Same thing when you shift over to IT in the same company, network operations and management, some communications, TCP/IP, pretty common protocol. That's all CIA. When you come over to the operations technology side, another change. It's AIC, I already talked about that. And you have industrial controls there, and then for electric utilities, including here in Alberta and British Columbia, there's a regulatory requirement called NERC-CIP. NERC stands for North American Electric Reliability Corporation. It's a regulatory agency out of the US, but it's for all of North America, Canada and Mexico. And it also includes, the CIP is for critical infrastructure protection. So for example, if I were to work for your friendly local utility, I'd be up to here in NERC SIP issues right now, trying to be compliant. Last but not least, the operations technology usually uses proprietary protocols. They are shifting a lot to TCP/IP now, but generally speaking, you could walk into an organization and they're using a serial protocol called Modbus or DNP3. There's like a list of 87 different protocols. So it's not the same as TCP/IP and using ping and everything else versus the proprietary side. All right. So now this is kind of a comparison time, and I just want to compare IT versus OT. There's a lot of words here. I'm probably not going to read every one of them, but want to give you a sense is that there is a difference. And when you're talking to someone, say you're an IT person talking to an OT person, the more you know and understand this, the better and more sensitive you are to the OT side. And if you're an OT side, you can go to the IT side and go, I understand your pain. So let me see if I can help you. And I'll tell you some stories about this as we talk. Okay, IT. Not real time. People are going to say, oh, of course it's real time. You know, I send an email, I expect it to go. That's right, but what if your email's delayed 1 minute, 5 minutes? It's not the end of the business, theoretically, okay? Response must be consistent, sure. High throughput is demanded. This would be like your ERP and that kind of thing. I'm sending a lot of data for a bank. High delay and jitter may be acceptable. Your voice over IP system accepts, has an allowance for jitter and for delay. It's less critical emergencies interaction, and then it's tightly restricted access control can be implemented to the degree necessary for security. If you saw the Active Directory discussion this morning, which was pretty impressive, you can build in a lot of security into these systems. On the OT side, it is real time. It's basically predicated on what they call RTOS, real-time operating systems. This is where there's an expectation. I send a signal, it's got to be processed. But these signals are really simple. Open, close, on, off, up, down. They're not really hard, lengthy equations. They're pretty straightforward. Response is time critical. I talked about that. High throughput is typically not essential. You're not going to get a lot of data going through. If you tried to scan OT signals, you'd probably be pretty bored because it's nothing is as interesting as, say, a bunch of stuff on your network. You cannot have any delay or jitter. The response to human and other emergency interaction is critical. I talked about the safety instrumented systems. They're really critical. And access to ICS should be strictly controlled, but should not hamper or interfere with what's called human-machine interface or interaction. Availability. We've talked about this a little bit. AIC, rule number 1. On the IT side, if I send out a patch, let's say Microsoft sends out an emergency patch, which they have done, and you go, we've got to get this out now. Your enterprise might do it, or they might wait till midnight tonight, or wait till Sunday or something like that. But they may reboot every computer in the enterprise. The company can still run, it can survive. For a refinery or a company that has to run 7x24, to send out a reboot command could break your plant, or it could result in environmental release, a fire, failure, people could get killed, etc. So when IT says, we need to patch, the OT guy says, or girl says, fantastic, we're going to patch in 18 months at our next outage. That's the conversation. And that's where the IT people can say, but it's a Microsoft patch and you got to do it now. And the OT person says, I can't do it now without breaking the plant. So that's something a very critical discussion. If you have awareness of both sides, you'll be a hero to each other. On OT, if you, like talking about rebooting is a problem, availability is a big deal, and again, outages are usually planned months out. So what I do is when I'm doing an assessment of an industrial facility, I'll talk to the OT guys and say, okay, show me your patch schedule for the next 6-8 months. And they usually have a folder or electronic folder, and it says, here's all the patches we have to go out and put in the systems, like into our workstations or whatever. And workstations do use Windows. But the point is that I can't do it today. I will do it in 6 months, 8 months, 18 months, or whatever. For risk management, pretty straightforward. CIA for the enterprise, AIC and safety for the OT side. I think I've beaten this poor horse to death. But essentially, major risk impacts. If we do something crazy on OT, it could result in some really significant issues. Sewage spill into the Bow River, a fire, loss of life. Okay, on system operation, pretty straightforward. So IT systems are designed for use with typical operating systems, Windows, Linux, Unix. Nothing really unusual here. Most of the time, people are trying to stay ahead with like the more recent versions and so forth. But on OT, they may be stuck in the past. I have literally been to a facility where the operating system for one of their process lines was Windows NT. And the comment was, what the heck, what are you doing here? Can't patch it. There's no patches available. You can't secure it. Well, the answer is it's going to cost us too much time and money to build a new system based on more contemporary operating systems. That's the reality of the process side. And what was the phrase? If it ain't broke, don't fix it, or whatever. So that's kind of the response. I've also been to a place where they had Windows 2000 machines that were infected with Configure. And I said, well, why are you letting this go on? And they said, well, every time we get rid of Configure, it comes back, which I still haven't figured out the answer to that. And then the second part of it is to say, well, it's going to cost us $20,000 to get a new API to go to the new Windows versions, when for this process, the cost benefit isn't even close to that. So we'll just stay with Windows 2000. Okay. Resource constraints. With new machines nowadays and computers and, laptops with, was it i7, this is a Core i7 V Pro. That's a ton of processing power. And I've been doing computers since 1980. So that's an amazing machine, right? Well, imagine the plants are still back in the 80s or the 70s. They basically have systems and computers and microprocessors and so forth that have essentially no memory in them. They have enough memory to run the on-off, open-close, up-downs, but if you were to try and send it anything, like a ping, you could tip it over. I mean, I was in doing work at a major sewage treatment plant several years ago, and we were just doing a scan, which is a different story in itself. And we were sending a ping sweep using Nmap out and tipped over a very critical PLC for the system. Why did that happen? Basically, it was a buffer overflow. It was a denial of service attack, if you wanted to call it that way. Very easy to do. So, and the reason why I have a goldfish here in an itty bitty box is that's basically what the life is like for the computers on the OT systems. There's not much room. So if somebody says, you don't have antivirus? How come you don't have antivirus on there? I said, it won't work. It will kill the machine. Same thing for encryption. Too much latency. Remember I talked about availability. You put something in there that affects latency, it's just not a reasonable thing to do. Communications, if those of you who are like serial devices or parallel ports and that kind of stuff, you will be in heaven in most industrial facilities. Modbus, a couple other protocols use a lot of serial connections. There is a Modbus TCP/IP, so that does exist. You'll see RJ45s out there. You'll see a lot of converters between serial and TCP/IP. But it's a whole different animal versus the IT side of the business. All right, another one, change management. I talked about patch management. And how many of you guys are familiar with ITIL? ITIL? Okay. Somebody would say, ITIL, okay, ITIL is the Information Technology, is it Infrastructure Library? I think so. Came out of the UK 2000 or so. It's really terrific protocol or methodology, but if you were to try to apply that over to the OT side of the house, first of all, the OT guys would ask you how to spell ITIL. And then the second thing is that it just wouldn't fit into the mindset for operating the operational technology side of the business. Now, there's some elements in there like change management, configuration control, really, really important for OT. And in fact, for those of us who go out and do assessments, I can assure you that OT configuration management is a huge problem. Because the mentality of the OT folks historically is broke fix. The device is broken, I take it out of the rack or out of the hole in the wall or whatever, I put a brand new one in, right out of the box. I haven't hardened it, I haven't patched it, I haven't configured it, I haven't done anything with it. So, and I'm not saying it's all like this, but this will give you a sense of the pretty common attitude. And because availability is so darn important, right? The line is down. Fix the line. Get the line back up. You have no time. Hurry, hurry, hurry. Whereas on IT side, yes, those times happen. I'm not going to argue that. But if somebody said, okay, our change management meeting is every Thursday at 2 o'clock. We're going to review the changes for the upcoming week. And we're going to talk about backout paths and all that stuff. In the OT environment, that's very uncommon. Very, very uncommon. And it's, again, because of the push for availability. You've got to be online. You've got to get going. You've got to keep things running. On the OT side, you tend to have one vendor. We may have a factory that uses Rockwell as our support, or Siemens, or Allen Bradley, or people like that. That's pretty common. Whereas on the IT side, you may go to Microsoft for a little bit, but you might go to another company or like a local company for your IT support. So it'd be very common to have a variety of vendors. Again, whereas on the OT side, it tends to only be one vendor you're leaning on because of your way your systems are architected. Lifetime of components. You can go into an older factory and you're going to find devices in there that might literally be 10 or 15 years old, and they're still running fine. I talked about Windows NT. This is not an unusual event when you go into an operational system. Now, admittedly, if you were to say go back east to some factories around, say, Montreal, you'll find the really old stuff there versus the newer side, where like out here in Calgary or in Vancouver, there's a lot more newer factories and so forth. So they may not have ancient devices. Or the antiquity level here might be 5 years, and in Montreal, it's 25 years. Point is, you're gonna find really old stuff. And if it's not broken, don't fix it. So there's a lot of that discussion that goes on all the time. Whereas in IT, it's, 3 to 5 years? Usually the refresh path for laptops is like 3 years nowadays. Pretty common. On the IT side, you have what's called zero-day attacks. 0 days, right? We hear about those all the time. It's basically this, somebody's discovered a vulnerability and they don't tell Microsoft, and then they release it on the universe and cause all sorts of problems. The joke in the OT side is it's 0-decade attacks. Oh, this equipment's 20 years old. I found a flaw in it. I'm going to introduce it. Well, there are systems out there that are so old, they still get affected. Component location. If you go into IT, usually it's a nice air-conditioned space. Humidity is established, set point. Temperature is established, set point. Ventilation's got established, set point. You have all sorts of, the hot aisle, the cold aisle, the air flows up, the air flows down. OT is not that pretty. OT is, like I show a picture here of a guy, I think that's you, Paul, out in the middle of the snow. Of a guy out in the middle of the field probably working on a sensor or an actuator. It's not unusual. It's basically, that's just the way it is, because remember, it's processing things, it's trying to make things happen, not necessarily process data. So when people talk about IT versus OT and winners and losers, I'm totally against that. First of all, your company is there to make money or provide a service if you're a government agency. You've got to be successful. That's what your job is. So to fight each other over who's better, IT or OT or whatever, reminds me of Donald Trump arguing with some of the people during last year's debates about sizes of certain aspects, right? It doesn't matter. What matters is how can we be successful as a team, right? I have literally been in environments where the OT guy says, I'm not going to deal with the IT people, they're stupid. Well, why do you say they're stupid? Because they want me to patch every Tuesday and I can't do that. Okay, well, that's cool. Talk to the IT guys, how come you don't like the OT guys? Because they're stupid. Okay, why do you say they're stupid? Because they won't patch on Tuesday. Well, did you ever understand why they don't patch? And so forth. And so what I'd encourage everybody in this audience, especially a lot of you who are a lot younger than me, I think everybody is for that matter, is take advantage of this, of the knowledge, and try and spend time with the OT or IT side of the house and learn about what the job is and what the problems are and what the solutions are. I'll give you a quick story. So I was working at a fertilizer factory doing a security assessment. And yes, there's a metaphor in there someplace. I don't know what it is. And the CISO on the IT side saw a problem between IT and OT. So I was talking to him, very nice guy, a lot of good ideas. And he was saying that he had to figure out a way to get IT and OT to work together. So they had a project on OT, on the operations technology side, doing an upgrade for one of their systems. And normally the upgrade would be take a new device out of the box, put it into the hole where the old device was, and turn it on. I'm oversimplifying phenomenally. The IT person didn't understand that, didn't understand what the system was, didn't understand the protocol or whatever. So what Jerry did in this case is he said, okay, I'm taking an IT project manager and assigning them to project manage this upgrade. And what was really amazing about this was multifold. First of all, here's IT talking to OT to realize that there's an ability to have a conversation. The project manager is a woman who, in the OT side, it's not very common to see women out there. So here's a woman working on the OT side, so they're thinking she's got cooties or something. And also, she brought in ideas like ITIL, configuration management, etc., and it was an amazing success. And the buzz on the OT side, because they were part of operations, was to the maintenance guys saying, hey, these people really have a lot to offer us. Let's keep on working together. So my encouragement to you is understanding the differences. They do exist. They require a lot of expertise. Both sides are extremely smart, so don't think that the other person is stupid. Just because of an IT process or doctrine doesn't necessarily work in OT and vice versa. But it's really important that you work together. So just one thing you walk out of here with, besides being a little bit smarter on the difference between IT and OT, is when I go back to my company, factory, refinery, or whatever, or I wind up working in a place like that, I'm going to try and learn the other side of the coin so that I can be an effective team member. All right, well, thanks a million for your time. I might have been faster than I was supposed to do, but just wanted to say thank you, and thanks again for the invite to come up to BSides, and I'm happy to field any questions or comments. Oh. So just a quick, I just realized I added these two, so sorry. Sit down. Don't leave yet. Number one, for people who ask me all the time, they say, how can I learn more about industrial control security? This is really interesting. Well, there's a document out on NIST, National Institute of Standards and Technology, called the SP 800-82 Revision 2, and it's a guide to industrial control system security. It's a textbook. It's free. It's really, really well done. So I highly recommend that if you wanted to learn more about this, go out there and make it a desk reference, because you'll be amazed how much you refer to it for your job. And then another place to go to is ICSCERT. So it's Industrial Control Systems, Industrial Control Security Computer Emergency Response Team. And they have a ton of things that are available out there, including online training that's free and so forth. Okay. Now you can ask questions. So anyway, thanks again. Yes, sir.
What do you think is the most serious example of where the industrial system has been hacked? The one I've seen on TV is the one done by Vice. It was the Shamoon virus, that attacked the Saudi refinery infrastructure. I heard we had a feed on our RS feed on our website that showed that some of the power grid in the U.S. had been compromised. I think it was Symantec that made the announcement.
So the question essentially, what's the worst one of all the industrial control attacks you think about? Okay. Well, I'm going to first go through a list. First of all, the primary one, the first real attack that raised awareness on industrial control system security was Stuxnet. That was an attack on the Iranian uranium fabrication facility or processing facility. And essentially it was an attack using a variety of 0 days into a Windows server that then connected out to some Siemens controllers of a certain variety. And that attack was not only to essentially, ultimately what it was trying to do is turn off or break all the centrifuges. And the way it worked was they did they copied the data for the centrifuge RPM, then went ahead and oversped the centrifuges, but still put a display up on the digital readers saying that the RPM was just fine. In the meantime, these things are just tearing themselves apart. So Stuxnet is the beginning of ICS security awareness. It was a big deal. Another one was Shamoon, which you just referred to. That's an interesting one because Shamoon was actually not an ICS attack. It was an IT attack. And I had the opportunity to go to Saudi Aramco right after they had their attack. And a couple of things. First of all, the Shamoon attack was somebody had it was either a USB or a DVD, I don't recall. And they were told it was pornography. In Saudi Arabia, you use that at home and get caught, you get your hand cut off, literally. So what they do is they bring it back to work. Now, if you've ever been to the Saudi Aramco site in Saudi Arabia, it's like stepping in California. I mean, they got a Safeway stores there. They've got a shopping center. Women and men work together. They don't have separate doors. It's a whole different world versus the Saudi Arabian side of the fence. So what this guy or girl thought was, oh, I can watch this at work. Nobody will know. Da, 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 da. As soon as they put in their computer, and their network was so flat, it wasn't segmented, that 35,000 IT computers basically had a kill disk on it, had a big picture of a burning American flag, you know, all these kinds of things, and wiped out 35,000 computers. They literally had containers sitting outside their building full of imaged hard drives from Dell or somebody that they had to ship over, and they literally going computer by computer, pull out the old hard drive, put a new one, throw it away. So that's Shamoon. It did not affect their ability to work on the IT side of the business because they had that DMZ, they had a good separation. They were lucky. Let's see. Another attack was probably the most recent big one was in the Ukraine, and they've actually had a couple attacks over there, two of which was on their electric grid. There's one, it's called Crash Override. If you ever want to go out and read about it, there was an article in Wired magazine about last December's attack. And essentially what it did is it took control away from the operation of the grid, away from the control center. And then what they had to do is they had to send people out and manually open or close breakers to take control of their grid. There was also some signals coming in to say, open up all these circuit breakers, so there was a blackout for part of the country for a while. The most recent one that I heard about yesterday in Minneapolis was there was an attack in the Ukraine also, and what they did is instead of attacking the electric grid, it attacked ATMs, cash processing systems, point of sale systems, and so forth, so that there could be no commerce except for true, honest-to-goodness cash exchange. And according to a friend of mine who was there, he said that the feedback from the Ukrainian, one of the ministers, was that this killed us. The electricity was bad enough, but they just totally knocked us to our knees because we couldn't do anything. So it's kind of interesting. So we're expecting more opportunities as far as attacks go for industrial control systems, but the other part is industrial control systems are shifting more and more to IT and IT-based. So what's happening is things like WannaCry. WannaCry was a ransomware that theoretically would not have affected an industrial control system. But there are ways that it could, and there have been stories of industrial control systems affected by WannaCry. So can you imagine getting a ransomware on your floor when the guy's supposed to watch the human-machine interface? In other words, a little screen in front of him. Open this valve when the tank gets full. Yes, sir. I can't tell. I can't read the sign. It's gone. It's ransomware. So if you're interested in a career, ICSCERT is going to be tons of fun. I'm kind of sad. I'm kind of an old guy, so I eventually will retire or die, hopefully in that order. Other questions, comments? Yes, sir.
So, something like the one in the attacking Ukraine, was there like anything leading up to that? Was it done for a ransom kind of, like, what purpose?
Let's see, a lot of conjecture on this. And the conjecture is that the Russians are using Ukraine as a practice ground, because they keep on just poking and poking and poking and poking. But the beginning of the first attack, I'm sorry, I've lost the name of it. It was like, I can't remember the name. But the beginning of the first attack was actually a phishing attack on the Ukrainians. And it was to harvest credentials. And then once they got their credentials, then they started going into the network and mapping it, figuring out what's going on, you know, who does what signals do what, and everything else. What type of equipment is in our substations, et cetera, et cetera. This took a lot of time. They figured it was on the order of months, maybe a year, just, you know, collecting all this information. And then when they decided to strike, it was like, boom, done. So what predicated that? I mean, the Russians obviously are unhappy about the Ukraine. Ukrainians are unhappy about the Russians. It's almost like an East versus West firefight. Questions or comments? Oh, sorry, yeah.
Why do you say change management's missing in operational technology? As far as I see, they're really good at managing their changes, logbook, daily, every other day meetings and all that.
It can be done. I'm not going to argue that. You see the disciplined aspect is like run books. That's the word I want. You'll find these guys, especially good solid system engineers, they got run books in all their different systems. They can tell you about configuration management and everything else. The part is that I rarely see that when I go to all these different facilities. It's not because they're not interested. Either A, they've never been trained, okay? Because most of the OT side are people who've started out as helpers out in the factory floor and then got smarter and smarter and smarter on how these systems worked and understands, limit switches, and we're putting a new PLC in, so why don't you learn how this works or go to the school or whatever. And so they just haven't had the exposure. And I sound like I'm generalizing, and I don't mean to, but I see that more frequently than I do the organized thing. I mean, I've been to one, that sewage treatment plant I was telling you about. In spite of having a bad PLC that we were surprised it tipped over, their architecture was textbook. I mean, it was actually I was supposed to do the architecture review and I got bored because it was perfect. It was Purdue Model 101. So I apologize if I've offended you or any of your friends, but I can just tell you that of all the places I go to, I see that less disciplined than the other. Oh, the other thing too is head count. Factories don't want to spend money on OT, right? Because those guys aren't production. They're just keeping things running. Let's make maintenance, right? How many maintenance managers do you know that make too much money? I don't know any. Other questions, comments? I think we're done. And I'll be around. If you want these slides, you can either send me an email or I guess I can leave you guys the set. Perfect. All right, thanks again.